Rajesh sir
I'm
also
not
is.
able to hear you.
Yes, that is the message he is giving. Yes, yes. No, sir, we are in unmuted connection only.
So do they're not able to hear me. I don't know why. Is it? I did not plug it in, but they are able to hear me, but I'm not able to hear them. Okay. Why I'm not able to hear them?
You can't hear them,
No.
but they can hear you.
Yeah.
What's this?
This is 100. I put 100.
Can you hear any other video normally?
No.
Connected to the Samsung box. Yeah, no, it should work.
What was that again?
You're connected by Bluetooth to the other speaker.
Show me. Show me.
I just switched off the Bluetooth steady.
No. Once again.
Dear participants, please mute your mic audios. Please, we are hearing a lot of noise. Please, participants, please cooperate with us.
Dear
we are
participants, yes, sir, yes, I will continue. Dear participants, please mute yourself and please switch off your videos for the smooth conduction of this program. We request once again, sir, to all the participants, please. Slight technical problem with our chief guest. He will join within 1 or 2 minutes. We will continue the program. Please wait. And please mute yourself and switch off your video. Questions.
Okay, I'm here. Can you hear me?
Yes, sir. We can hear you. Yes.
Okay, yeah. I have sorted the problem out from here, so it's okay now.
Thank you, sir. Thank you, sir. Yeah. Sir, within 1 minute, 1 or 2 minutes, we will start, sir.
Yeah, and I have to see how I have to share my screen also, because
yes, sir.
This platform is something not I use very often, so I think there has to be some learning to go. Okay. So should I click on the present now and then put my screen there?
Sir, present now, then go to window option.
So I go to the present now and I go to the window option.
In that, if your PPT is already opened, it will show the tab also in the share options. Your PPT should be open in previous.
Yeah, it is open, and then I put on the share option now.
Yes, sir. Yes.
Okay,
yes.
Perfect. So I just go on the full screen mode.
Yes, sir. We are seeing it's coming.
Okay.
Yes.
Perfect.
While presenting, please be in a presentation mode. It will be better, sir.
Okay.
Letters will be visible. Yes.
So shall I say stop presenting now, or I keep it there?
No need, sir. First, we will take out the inauguration program, sir. In those inauguration program, we need very few words from your side. After that, I will go with the vote of thanks. Then we will start your full sessions.
Okay, so I should be able to see my PPT on my screen, because at this point of time, I'm not able to see that.
Actually, at this point of time, we need to present our inauguration screen. That is
okay.
Yes,
so you will bring that after the inauguration, right?
Yes, sir. Yes.
Okay. Perfect.
Again, we will give you the time to present your screen. Once again, we will present after inauguration.
Okay.
Okay. Thank you. Time being, I request our Rajesh sir, admin sir, please share our screen, sir. The inauguration program, we can share it. Sir, HOD sir, shall we start, sir?
Just wait, sir. Just wait.
Okay, sir. Okay.
Sir, Madhivanan sir, we'll start, sir. Madhivanan sir,
Yes, sir. I am here only, sir.
I can start
Yes.
now.
1 minute, sir. I need to confirm with Haripriya for a prayer song. Just already informed, sir. I think that she has joined. I will confirm. Okay. Thank you, ma'am. Thank you. Sir, shall we start,
Yes,
sir?
yes, go ahead, sir.
Yeah.
Okay. Sir. Thank you. Sir. Good morning to August gathering and welcome you all to this short-term training program on nanotechnology and functional materials phase 3 organized by Department of Mechanical Engineering, SV College of Engineering. First of all, I welcome our chief guest Professor Manoj Gupta sir from National University of Singapore for this inaugural function. I welcome our principal of SVCE, Dr. N. Sudhakar Reddy sir. I welcome our principal of SVEC, Dr. T. Kalpalata Reddy ma'am. I welcome our head of the department and convener of this program, Dr. M. Chandrasekhar Reddy sir. And I welcome all the participants to this third phase nanotechnology and functional materials program. The main objective of this third phase short-term training program is to provide an opportunity for faculty to interact with the leading researchers in nanotechnology. This STTP includes invited talks from experts in related areas from reputed institutions. It is our tradition to start any program with a prayer song. I request our student Haripriya for invocation. Haripriya, you can continue.
Yes, sir. Sham Bharadaram Vishnum Shashivarnam Chaturbhujam Prasannavadanam
Haripriya, are you
Dhyayet.
there? Haripriya, you're not listening.
Sir, it is going, sir. It is going, sir. Prayer song is going, sir. Haripriya, you can please continue.
Sarvavignopaşantaye Agaja Anana Padmarkam Gajanana Maharnisham Anekadantam Bhaktanam Ekadanthamupasmahe Ekadanthamupasmahe.
Thank you, ma'am. Thank you for your prayer song. Now, let me introduce the convener of this program and head of the department, Dr. Chandrasekhar Reddy sir. Dr. M. Chandrasekhar Reddy sir holds a PhD degree in thermal engineering from JNTU Hyderabad. Dr. M. Chandrasekhar Reddy was awarded Adarsh Vidya Saraswati Rashtriya Puruskar from Global Management Council, Ahmedabad. He has more than 20 years of teaching and research experience and guiding many PhD scholars. He has published more than 75 papers in reputed international national journals and conferences. I request our convener, sir, please opening. Dr. M. Chandrasekhar, sir, please opening the remarks, sir. I request you, sir.
Thank you, Madhivanan sir, for nice introduction. Esteemed Chief Guest, Professor Manoj Gupta, National University of Singapore, beloved Principal of SVCE, Dr. N. Sudhakar Reddy, and a dynamic Principal of SVCE, Dr. T. Kalpalata Reddy, enthusiastic researchers, and August gathering, very good morning to one and all. I, Dr. M. Chandrasekhar Reddy, convener, welcome you all to this AICTE-sponsored short-term training program on nanotechnology and functional materials from 14th September to 19th September, organized by Department of Mechanical Engineering, SV College of Engineering. So SV College of Engineering is ready to take every minute aspect into an opportunity. As such, is this STTP in this pandemic. Research means that you don't know, but willing to find out. The main objective of this STTP is to provide an opportunity for faculty to interact with leading researchers in nanotechnology. The STTP includes invited talks from experts in related areas from reputed institutions. So we have successfully conducted two STTP programs, and this is the third phase we are conducting from 14th to 19th September. So I take it as a pleasure to put a note that more than 1,000 participants, like scientists from R&D, faculty members, research scholars, postgraduate engineering students, are taking part in this STTP. Advanced functional materials continue to attract huge scientific interest by feature of its potential to provide path-breaking innovations. The exchange of knowledge and information in this field is thus very important for researchers, academicians, and entrepreneurs to develop new materials and technologies for future applications. The course aims to bring together national experts from R&D organizations, academic institutions like NITs, IITs, and IICC, and industries in the field of material science and endeavors to facilitate interactions and discussions on the recent trends in functional materials. Once again, I thank AICTE Chief Guest Professor Manoj Gupta, Management of SV Colleges, Principal of SVCE and SVEC. All my dear participants, have a great weekend. Thank you, one and all. Thank you, sir.
Thank you. Thank you, sir. Thank you for your warm welcome, sir. Now, let me introduce our principal of SVCE, Dr. N. Sudhakar Reddy, sir. Dr. N. Sudhakar Reddy, sir, holds a doctorate degree in data mining specialization from JNTU Anandapur. He was awarded the CMI Level 5 certificate in management and leadership. More than 20 years of teaching and research experience is having and guided many research scholars. He is the prestigious ISTE Best Engineering College Principal Award in AP and Telangana State for the year 2017 from the Honorable Vice Chancellor JNTU from Professor S. Srinivas Kumar. Now I request our principal, sir, to give a valuable speech, sir, please. Requesting, sir.
Okay. Thank you, Dr. Madhivanan, for your introduction. Today's distinguished chief guest, Dr. Manoj Gupta Garu from Singapore, and Principal of SVEC, Dr. T. Kalapratha Reddy Garu, and HOD of Mechanical Engineering and convener of short-term training program, Dr. M. Chandrasekhar Reddy Garu, and other faculty members of Mechanical Engineering Department, and participants from reputed engineering colleges and R&D institutions. Very good morning to one and all, and my hearty welcome to AICTE sponsored short-term training program on nanotechnology and functional material, a third phase. We have successfully conducted two phases, and this is the third phase, and we will conduct one more phase also soon. The four phases we are conducting on nanotechnology and functional materials. My sincere thanks to AICTE for providing financial support to conduct this STTP. More than 15 resource persons are from IITs, NITs, and IISc, and from foreign universities like our Manoj Gupta sir. I request all the participants to utilize this opportunity and gain knowledge on nanotechnology and functional materials. Once again, I request all the participants, please participate this STTP from 14th to 19th September and gain knowledge. My sincere thanks to convener and Mechanical Engineering Department for conducting this STTP successfully, and my gratitude to Dr. Manoj Gupta Garu for accepting as a resource person and chief guest for today's program. Once again, thank you very much and all the best.
Thank you very much for your speech, sir. Now, let me introduce our principal of SPEC, Dr. P. Kalpalata Reddy ma'am. Dr. P. Kalpalata Reddy ma'am has more than 23 years of experience as academicians in teaching profession as well as administration, and a major contribution of several years goes to research and development. She has received Dr. D.A. Rajan Promotional Award by IET, UK. She has received a Best Reviewer Award from Institutional Journal for Soft Computing, and she has received many awards. These are the few glimpses. Best LabVIEW Academic Award from NI India 2014. She has received IE Institutional of Engineers Award of Appreciation from Sea Tides for proactive effort in learning initiatives, placements, campus, research and development efforts. I request our principal ma'am, please share your valuable thoughts, ma'am. Requesting, ma'am. I request principal ma'am. Sir, Rajesh sir, is there any technical problem, sir?
It is clear, sir.
Okay, sir.
Maybe madam.
Yes, sir. Yes, sir. Just 1 minute, sir. I'll just make a call to now, sir. Sorry, just now I discussed with our principal madam. She got sudden technical problem. She couldn't able to join. Now we will go with the next part. I request. Let me give a short note of our chief guest, Professor Manoj Gupta sir, from National University of Singapore. Our Manoj Gupta sir has completed his PhD University of California at Irvine, USA. He has completed his Master of Engineering IISc Bangalore, India as a gold medalist. He has given more than 550 journals, international journals and conferences around 200 plus. He has completed his book chapters, 7 book chapters and 6 edited books, and very astonishingly, his citations are 17,340 and HA index is 67 and I index is 318. It is a very extraordinary, sir. And he has worked with as a visiting professor many universities. These are the few glimpses. King Sword University from South Africa as a visiting professor, Kobe University from Japan as a visiting professor, and University of Lille, France. He had an invited researcher, Indian Institute of Science. He has just Brahma Prakash Chair Professor, and Weltech University Chennai as invited professor, Wuhan University China as invited professor. He has many collaboration with the international national universities, and these are the examples in India, Qatar, and UAE, USA, France, all the countries. We are honored with your presence, sir. Now I request our chief guest to give a few words. Requesting, sir.
Yeah. Thanks a lot, Rajesh, for introduction. I'm very thankful to the principals of the college, Kalplatha Reddy and Dr. Sudhakar Reddy, and the head of the department, Chandrasekhar
Madhuvan
Reddy.
sir is not audible. Tell to the sir.
Sir, it is audible only, sir, I think.
Yeah.
Yes, sir. Sir, please, you continue.
Okay.
Please.
It is audible. Okay. No.
Yeah.
Please, sir, continue. Sir.
Yeah. So I thank them to providing me this platform to address the academician which have registered in your conference. I think there is some.
Sorry, sir. Dr. Prasad Reddy, sir, please stop your presentation, sir. I request all the participants, please mute your audio and switch off your video and don't share anything on the screen for the smooth conduction of the program. I request once again, sir. Otherwise, you will just you will be eliminated from the classrooms. Yes.
So,
Sir, please.
Yeah. Once again, my sincere thanks to everyone who provided me with this platform, and it is an absolutely important step on behalf of your college to conduct such kind of a conference, because knowledge dissemination is extremely important for the development of the society and the nation as such, and bringing the people from the different parts of the country and different parts of the world is extremely meaningful. It bridges the gap between the scientific community with the possibility that we can make much better and positive changes for the prosperity of the people in our country. So I'd like to thank everyone for inviting me, and at the same time I also expect that my presentation will be quite useful for many of you, and if you understand not the topic but the gist of the presentation, I think it may help you in becoming a much better researcher and move into a research direction which is going to be important for the future generations. So I think with this I will stop my presentation, and whenever allowed I'll start with my actual presentation.
Thank you very much for your inspired words, sir. Now I will proceed with the vote of thanks for inaugural function. I sincerely thank our chief guest, Professor Manoj Gupta, for kindly accepting our invitation and gracing the inaugural function. I thank our college management for providing us the necessary infrastructure for organizing this STTP program. I thank our beloved principal, SVCE, Dr. N. Sudhakar Reddy sir, and our beloved principal, SVEC, Dr. T. Kalplatha Reddy ma'am, for their enthusiastic participation in this inaugural function. I thank HOD and convener, Dr. M. Chandrasekhar Reddy sir, for his valuable participation in this inaugural function, and all the organizers for making this program into reality. Thank you. I thank finally, on top of all that, I thank all the participants who have given their valuable time and effort for participating in this program. Thank you. Thank you very much, sir. Sir, now I request our chief guest, Professor Manoj Gupta, sir, to deliver his keynote address. Please, sir.
Okay, I'm just trying to log on now.
Yes. Yes. Now you can share your screens. Yes.
Okay, I'm sharing. Can everyone see my screen?
Yes, sir. It's coming, sir.
Okay. Once it is there, just let me know.
Yes, sir. Yes. Yes, sir. It is okay, sir.
It is there? Okay, fine. So
yes.
I start my presentation and I request you people to mute your audios so that you can clearly hear me even if there's any technical glitch. Okay, so as introduced, I am Manoj Gupta with about 27 years of experience in National University of Singapore. I'm trying to address a topic here which is very important for all the researchers, irrespective the area they are working on. And since I am a material scientist by training, so my focus of this talk is on how we are looking into the materials in the current scenario. So if you look at my talk here, sustainable and eco-friendly magnesium-based nanocomposite for engineering and biomedical application, you will notice the word sustainable. Everyone talks of the sustainable, something which can be sustained. If you work in an area which cannot be sustained, it is going to die anywhere. The second word is eco-friendly. The eco-friendly word is everything that now we use has to be nice to the nature. When I say nice to the nature, that means it should not be toxic to our environment, because people have used many toxic materials and technologies in the past, and now we are spending like billions of dollars to clean up our air, to clean up our soil, and clean up our water. So if we keep doing that, maybe our planet will not be a good place to live in next few decades time. And then the third word is magnesium. So the purpose of this talk is to target magnesium because it gives one of the many options in which we can address sustainability, eco-friendly thing, and we can use this material in engineering and biomedical application. So that is what you can derive out of my title. Now, if you look at the pictures on the bottom of the slide, you see that magnesium, the use of magnesium is not new. It has almost 100-year history with the glorious use of magnesium coming in the Second World War. And you can see that all these ladies there somewhere in the Europe are working on magnesium-based material, where the magnesium-based materials were used for tracer bullets, bombs, and the lightweight equipment. So the concept of lightweight, which we are talking now, existed during the Second World War because of the very simple reason that we had the scarcity of fossil fuel there. Even the Germans came out with the synthetic petrol during the Second World War time because the fuel cut to them. So the concept was very well received at that time, and that is where the magnesium came into the application. In 1947, we have seen the Convair aircraft here, which used magnesium. So it was used in the aerospace sector. And the famous Beetle car almost used 20 kg of magnesium. So now these three pictures shows you the application of magnesium in defense technology, in aerospace sector, and in the automobile sector. And that is where the modern researchers are trying to bring it back. Now, how do we choose a material in 21st century? The previous rules are gone. So for a suitable material, for example, if you want to choose a suitable material, it has to be abundant. Abundant means sustainable. That means if we start some research in this direction, we should be able to sustain it. There's no point in starting a research which is a 10-year life, because by the time you perfect it, it is gone. So abundancy, sustainability is a very, very important issue. The second thing, non-toxic. This we have learned over the last 40 years when most of our river bodies, water bodies are contaminated and people are having side effects, the illness have increased, the cancer rates have increased, and now people are trying to clean up these bodies. So the material or the technology that we use should be non-toxic. Then these materials should have acceptable properties. They can be abundant, they can be non-toxic, but if they don't have acceptable properties, they cannot be used. Cost-friendly. Now, you can have gold, but gold is too expensive and it cannot be used. So you have to have a material which has to be cheaper, which can be used by a common man. And when it can be used by a common man, then only its effect on the society can be seen. And another interesting point which has recently been surfaced is the geopolitical issues. You may have a material in a lot of quantity, but if it is restricted to only 1 or 2 countries, then the people are scared now that should we really use that material? Because, for example, if a country X has 90% of the supply of a material and something goes wrong politically between your country and that country and they stop the supply, all your technology efforts goes waste right then and there. And that is exactly why people try to see that materials are available, but not restricted to one place. You have multiple resources of the material. And once you have multiple resources, then only they further the technology. And this is surfaced in last 20 years because of the rare earth materials, which are controlled by China mostly. And now with all the political situation all over the world, people are scared what happens if they stop this rare earth supply, and suddenly there are a lot of technology which are going to suffer badly. So these are some of the factors which we need to consider when we choose a material, and in this, magnesium fits the bill in all these categories. Now, why we should choose magnesium or magnesium-based material? Because they are very useful for making our planet a happy planet, for happy plants, for happy humans, and for the happy animals. Now, how magnesium can make the planet happy? The biggest problem we are facing now is the global warming. We have seen in Chennai, for example, there was a flash floods in 2015 because of excessive rains, and last year it was near drought. We have seen in Alberta in January 2016 forest fire when the outside temperature was minus 10 degrees centigrade. But the atmosphere was so dry that the fire spread very fast. And then we have seen France sizzling at 45 degrees C in 2019, which was unforeseen temperature in the European continent. So basically all these things, whether it's a forest fire or the flash flood, lead to a lot of economic disaster to the locality where it is happening. For example, in Chennai, the low-level industries faced tremendous loss. Even IT Chennai was almost immersed in water, and a lot of things which were underground at that time, a lot of equipment got wasted, and that was millions and millions of dollars. So global warming is an issue. Another evidence of the global warming is what you can see here. What you see here is an iceberg, and you can make an assumption how big this iceberg is by looking at the size of the people here. And you see that this kind of icebergs are being seen in the areas close to the Arctic Circle. Now this place is in Canada, and this is the evidence of global warming and Arctic ice melting. And this is once again because of the global warming here. And this is not a good news, because this leads to the increase in the sea level all over the world. Now, because of this melting of the ice in the Arctic area, the plate of the ice are getting thinner, the sunlight can go inside, and there's a lot of growth of the phytoplanktons now. So basically the ice is turning green now. So what does it mean is that this is another evidence now of the global warming, and you can expect that the whole of the Arctic area will, instead of being white, it will turn green, and once it turns green, that also means that all the ice may melt away from the Arctic zone, and all this ice goes in increasing the sea level. So based on this phenomenal increase in the effects of the global warming, the countries got together somewhere in the first decade of this century, what they call as the Paris Agreement, which was ratified in 2016, with a particular aim setting that let's keep the temperature 2 degrees centigrade below the pre-industrial time, which is set at 1880, and not to exceed 1.5 degrees centigrade, because once you increase beyond 1.5 degrees centigrade, then the temperature or the lead to some kind of a catastrophic events on this planet, which are already increasing to a level which will affect practically each and every human being. Currently, we are 1.2 degrees C higher than the pre-industrial time. So we have about 0.3 degrees centigrade to play with before we see much more catastrophic event in our day-to-day life. And the people also predict that for various reasons, if we don't stop at 1.5 and we cross 2 degrees centigrade, then that is a tipping point. And when I say the tipping point, now you cannot control the environment. It will turn bad for good. So that means we will be out of options to control it, and we have to face the consequences of that. One of the way to control this global warming or the increase in the temperature is to reduce the CO2 emissions by about 2 billion tons. Now, we have seen COVID now. The COVID came in last November. Most of the people, most of the economies are suffering, but there's a blessing in disguise here. what is the blessing in disguise here? Because your air travel has stopped, your ground travel has become extremely less now. So all these things is translated in less burning of fossil fuel. So the target of Paris Agreement, which was to reduce the CO2 emission by 2 billion ton, we may achieve that within this year. So it will give us a temporary respite unless we start again at an aggressive pace. So basically, the global warming is caused by fossil fuel, as I indicated, and because of the release of CO2. What are the important sectors which release this CO2? This number keeps changing, but you can see the four big contributors like electricity generation, transportation sector, industrial sector, and to a lesser extent, the residential and commercial thing. In all the four areas now, we are trying to make efforts. For example, we are trying to tap solar power, wind power, water power to ensure that our dependence on the fossil fuel is reduced. Yes, we are doing it. In the industry, we are going for much cleaner fuels so that the CO2 emission can be reduced. In residential and commercial sector, for example, now many of us are using the LED bulbs, so that will also reduce the electricity consumption, which indirectly depends on the fossil fuel. So the efforts are made. Another big sector where the mechanical and material engineer can come together is the transportation sector. The transportation sector is one of the biggest sector which generate the CO2, and this is also one of the rapidly growing sector at a rate of 20 to 25%, both the road transportation and the aerospace transportation. And that is where the challenge is. So basically, the concept is very simple. To reduce the global warming is to reduce the weight of the vehicle. This vehicle can be your car, or it can be a plane, or it can be a tank if we talk of the defense sector. When you reduce the vehicle mass, for example, the fuel consumption reduces. So the fuel consumption, once it reduces, you burn less fuel and you bring down the CO2 emissions down. So as a result, somewhere in 2010, that was the time when all the countries were coming together for the Paris Agreement, the European Union kind of decided that let's cut down the fuel consumption by 20 to 25% by the year 2020. They gave themselves 10 years time. So their aim was to reduce the CO2 emission from 130 grams of CO2 per kilometer to about 95 grams of CO2, which translates to about 35% in terms of CO2, and which translates to a mileage of about 30 kilometer per liter per the vehicle. So at that time, it used to be about 10 or 12 kilometer per liter. Now, to understand the gravity of the global warming, I've brought up this slide. You will be surprised to know that we have entered the 6th mass extinction event. When you say a mass extinction event, that means we can lose 70 to 95% of plants, animals, and microorganisms. Now, out of the 6 mass extinction event that humanity has seen, the previous 5 were by the nature, and this is caused by the humans. So 6th one is caused by the humans. And for your knowledge, the last mass extinction event even saw dinosaurs disappear. So don't be surprised that if we don't take any action, even the humans will disappear. We have seen that carbon dioxide levels are highest in last 800,000 years. And because of this high CO2 thing, global warming is more, and the Arctic Ocean can be free from ice by 2030. That will increase the sea level. Its impact on the low-lying country, including our own country and the country like Maldives, Fiji, Bangladesh, you may lose them, most of it actually. And we have seen that from 1990, there's a reference point to about 2015. We have seen the number of extreme events, droughts, forest fire, floods, tropical storms have doubled. And with every 0.1 degrees, you will see much more catastrophes. And if you're reading the newspaper in last few days, you have witnessed the fire in Oregon and California. It's all because of the dry weather, and the dry weather comes from the global warming. So there is something called the Doomsday Clock, which is 2 minutes to 12. That means if both the needle meets each other at 12 o'clock, that is the doomsday. Now this clock, or the needle of the clock, is moved based on three major factors: proliferation of nuclear weapons, the climate change, and the new technology. So you see, the climate change has a very important role to play, because nuclear weapons are still restricted to some countries, and if you explode a bomb, it will affect locally, but the climate change is affecting globally. It does not see any boundary. And the new technologies, once again, as I indicated, you use a bad technology, it ends up contaminating the basic requirements that you need for survival. So that is the doomsday clock. Fortunately, it has not moved for last 2 years, but about 2 years back in 2018, it moved by 30 seconds towards 12 o'clock. Now let's try to look at the mythology. Maybe some of you are aware that there was something called as the Mayan culture and the Mayan calendar, which predicted the doomsday to be on 21st December of 2012. Nothing really happened. But that was a time when the realization already started in early first decade of the century that we are heading to something very wrong. Now let's look at the Hindu beliefs. I think I pressed the wrong button here. Never mind. How do I go back? Give me a second. I'm trying to find out where my presentation is gone. Here it is. Yeah. So apparently, what you see here is that that's what they predicted. And now let's go to the Hindu beliefs. And the Kali Yuga is supposed to end in 2025 now. The Paris Agreement says that by 2025 we have to take concrete steps. So what does it tell you is that you see the scientific reality and the spiritual predictions are coming together now. And maybe 2012, the end or the prediction of Mayan thing, and 2025 is a window given to us to take the corrective action. If we don't take the corrective action, we have to face the consequences. Now, this thing is extremely visible. To use the right technology to reduce the use of fossil fuel, to go for green technology all over the world. I'm sure this movement is there very significantly in India also, but you can see the people in Europe, the people in USA, the people in African continent, and the people in the European continent regularly have protest to control the climate. Magnesium technology is good for the plants. The research done in Australia, for example, has the plant has the capability to absorb this thing, and they have shown that for the metals like gold. So gold can be absorbed by the plants. It goes in the leaves. Your manganese can also go into the plant in the transportation system and the leaves. So basically, if you grow your vegetables in an area or the soil or in the water which is contaminated, you may end up having this contamination within the plant. Now, one of the elements that we commonly use in the lightweighting is powerful electromagnetic shielding. It has reasonably good ductility, reasonably good modulus, and reasonably good cost, slightly higher than aluminum. The only negative it has is that it tends to corrode more. So you have to use this material with proper alloying or proper surface protection. Now, if you compare magnesium with the workhorses in the engineering application, aluminum, steels, and then titanium, you will see that it has the lowest density. So it's the most efficient in controlling global warming. It has the lowest melting point. So again, energy efficient. It has a specific modulus similar to all these elements, and it has a specific strength higher than aluminum and only lower than titanium, but titanium is very expensive. Now, it also has a processing advantage like good castability and machinability. Why this is important? Because it can be turned into finished product faster. What is the advantage of turning a finished product faster is that you save on the money, manpower, equipment time, so your product will be cheaper. So next question, are we short of magnesium? Remember, abundance, sustainability is a key issue. No, sixth most abundant element in the earth crust and third most dissolved mineral in the seawater. Now, you'll be surprised by mass. Magnesium is 12 times more than aluminum in our planet. So that means if we can use aluminum for 100 years, you can use magnesium for 1200 years, assuming that you are using at the current rate only. And of course, iron is the maximum. Now let's go to the universe. If you see in the universe, you'll be surprised that magnesium is much more abundant than iron. So in future, if you want to colonize Moon or Mars, you can take the magnesium technology because you're going to find it there and it's non-toxic. So that's why I say that it's a God's own element. It's the only metallic element or the most abundant metallic element, not on the planet Earth, but in the whole universe. So now this picture has come from a very famous Hollywood movie, Finding Nemo. This clownfish is asking, why you gave up in the 90s to start working on magnesium-based material. To further strengthen that why this material and associated technology the seat areas, because it was very clear the carbon footprint everyone want to reduce, and by just replacing the seat frame from aluminum to magnesium, they can save 360 kg for a A318 aircraft and about 4.2 tons for a 700-seater Airbus aircraft. And that will translate to a significant reduction in the carbon footprint. Now let's go to the maritime. Now, amphibious vehicles are the vehicles which can be used in both land and air, and they need to be lighter. And that's how they can use the fuel much more efficiently. So there's a lot of use of magnesium-based material in the amphibious aircrafts. You see the cruise ships, again, the engine is the magnesium construction. Armed robotic vehicle, a initiative taken by Singapore government, once again to reduce the weight of armed robotic vehicle, which can carry the medium caliber gun system in the war area. So if you have a lighter vehicle with the same fuel, you can stay in the war zone, you can travel in the war zone much more than a conventional vehicle. And with the calculation made, they said that the weight saving is 1 ton for a 6-ton armed robotic vehicle and about 3.75 ton for 25 ton. So many countries are doing it, including a small country like Singapore. Now, these are only some of the applications. I have not even talked about application or structural component in electronic sector, like the frame of the camera. The Samsung phone uses magnesium casing. Robotics, for example, currently steels are used, but you know how much energy you need to move the steel component? What happens if you replace with aluminum or magnesium? You will need much lesser energy. High-speed trains, the Japanese people have already been putting the magnesium-based sleeping buds here, and they have done the full-scale simulation of everything to be working well. And this is how the new are coming. So these are about the application, which hopefully will help you in appreciating what you are listening today about the magnesium and anything related with magnesium. We started work on magnesium-based material for almost 25 years. And any metal-based material can be synthesized using the liquid metallurgy route or the powder metallurgy route. And we also looked into the nanotechnology by using the nano lens scale reinforcement. This processing we devised here in Singapore, in which we take a crucible, put the material, and we use a resistance heating furnace, which is not expensive at all. And then you homogenize this metal mixture, you pour it at the bottom. When it is pouring down, you hit with in the car is much higher with this material than the normal material. Sometimes the temperature of the application goes up. So we gave some sample to Professor Malik in ISM Dhanbad, and we worked on magnesium ETS system. And this graph was created, and this shows that the composite has a higher strength at all the temperature till 250. Typically, magnesium and aluminum-based materials are not used beyond 100 to 150 degrees centigrade. So even at 250, the composite has a 1.5 times strength than that of the monolithic material. Now, similarly, the creep performance is very important. That means if you have a constant load and the high temperature, how your material is going to work. And this work we did in collaboration with Magic Germany, Magnesium Innovation Center. And we gave them this alloy in which we put tin and yttrium. And as usual, we found that by alloying, you increase the hardness, you increase the compressive yield strength, and fracture strength remains similar. And the magic happens when you put zinc oxide. You have 148% increase in the hardness, 59% increase in the yield strength, and UCS, and your ductility jumps to 27% now, which is about 34% increase. So when they did this creep thing, they found that all the nanocomposites, the properties, but also the high temperature properties have been enhanced due to the use of nano reinforcement. Another application, engineering application, is when the two parts slide against each other, like the railway tracks, like the reciprocating pistons, and so on and so forth. So tribology is very important. So I gave some sample to a tribological expert in the department, and then they found that just by putting 1.5% of Al2O3 in a magnesium alloy, you can improve the wear resistance by 25%. And if you do some alloying modification by addition of calcium, you can get another 25%. So you can make the life 1.5 times just by putting very small amount of calcium and the Al2O3. Machining behavior. The first work we did was Professor Aravindan in IIT Delhi. And you have to remember, once you make a material, you have to machine it into a component, and then you fix it with it. So machining is also very important. So they want to investigate the machinability of the deep aspect ratio holes. Their observation is that, yes, we can do that. No abnormal arcing or the random spark discharges, and the surface roughness is quite controllable. We also gave more samples to the Newcastle University, and they found that for all the composite we gave them for boron nitride, zinc oxide, the cutting force was always lower for the nanocomposite. So that means the machining, the energy you spend in the machining is also lower, except for one case of Mg2.5 ZNO. And surface roughness was also equally good, so that was not an issue. Then how this material is going to behave in the dry condition. So we did some oxidation studies. And if you see this magenta curve here, you will see that the weight change up to 470 degrees centigrade for the nanocomposite remained lower than the monolithic material. And that was attributed to the finer microstructure of the material, which led to the formation of thin and compact oxide rather than the thick and hollow oxide layer. This work is similar to the findings made by Australian researchers who found that oxidation capability or oxidation resistance capability of stainless steel improved with the refinement of the microstructure. So these are similar observation on the two different class of material. 0.1 gram per cc roughly, and we are able to match the plastic. So now we are working on these kind of material to make it ultra light. So in conclusion, I would like to say that there's a lot of scope of magnesium in general and nanocomposites in particular for many of the engineering and biomedical application. These applications, different countries, different researchers, and different companies are trying to put their footprint, but very few of them are in the market, and many of them are in the corporate sector. So essentially, there's a lot of room to grow. This technology does not need $1 million investments and all kind of things or equipment. You can use a conventional method that you used to use for aluminum, and then you can convert into the magnesium facilities. And as you have seen, the nanoparticles, for example, can simultaneously improve many of the engineering and biomedical properties. We are also trying with amorphous and the hollow reinforcement. That's a work in progress. So my message is the magnesium technology is arrived. Some countries have been very smart in taking a good position in magnesium technology, and the most visible one are China, South Korea, and Germany in biomedical area, and US limited information, but I think they are going more in the defense technology as well. But if you look at India, there is not much movement as yet. And that is where I can see a slight increase in the research in magnesium because of many of my talks in the last 4 or 5 years. But I think there has to be much more serious initiative from the government of India, which I'm going to convey to them in next month WebHub Summit, in which I'm going to raise this point. This conference is starting or inaugurated by Prime Minister Modi on 2nd of October. So beside that, I would like to thank all my past students and collaborators for working in this area, and thank you everyone for listening to me very patiently. So that's where I conclude my talk.
Thank you, sir. Shall we go with the question and answer?
Yes, absolutely.
Yes. I request the participants, please, you can type your questions in the chat box, or you can unmute yourself and you can ask questions directly to our resource person. I request the participants, you can unmute yourself or you can type your question in chat box. Sir, actually, we are getting many messages in the chat box, sir.
Yeah.
Yes, sir.
Yeah.
Sir. Hello?
Yes, sir. Please.
Yes.
Please.
Morning, sir. My name is Srinivasara from Hyderabad.
Yes.
My question is regarding the fabrication of MMC of magnesium, sir. Whether I can use the same method for aluminum steel casting, or we can use a different steel casting method?
Same. Only thing is that aluminum is relatively inert, so I don't know whether you people are using under the flux or in the inert atmosphere, but we are using it under the inert atmosphere. You can use argon or nitrogen. Both of them work very well, and they're very cheaply available.
Okay. Can we use the same magnesium in implants of like I just said bone transfer?
Yeah. You can use, but you have to ensure that the elements that you put in magnesium are not toxic elements. So if I'm at your place, I will not try to use the rare earth alloying elements in magnesium and aluminum also in magnesium if I to consider this material for implant application.
Okay. So can you suggest me which material is suitable for implantation of bone tissues?
You can put the zinc and calcium there. There are also a list of other elements which you can put to create new alloys which can go into the body. But at the same time, when you develop a material for the bio application, you have to first do the mechanical testing, as I've shown in the results, corrosion testing, which we call it the in vitro testing. And after that, you move on to the animal studies, because that is the regulatory pathway to take a material from the lab to the humans. You cannot have a shortcut.
Okay, sir. Sir, if in case any emergency, can you use the facility in a Singapore laboratory?
Well, we have the thing. Currently, visitors are not allowed because of the COVID-19 situation.
Yes, sir. After completion of this one.
Yeah, after that, it can be with the proper official approval, yes.
Okay, sir. Thank you, sir.
Thank you, sir. Sir, one more question from chat box, sir.
Yeah.
It is from Gurulingam, Professor Gurulingam. How
Yes.
magnesium-based composites are recycled to take care of eco concerns?
First thing is that there are no eco concern, because as I've shown in my slide, that even if it enters the food chain, it is going to increase your magnesium intake, which you need 400 mg per day. So that's a lot of magnesium you need. So that is the main advantage of magnesium. But obviously the recycling is important, and you can do it in any conventional way. There's no special way to recycle magnesium. The concern comes because you know that many of the industry dump all the waste in rivers and bury it in the soil, which can enter the food chain. So if you illegally do that for magnesium also, nothing is going to happen because it's a nutritional element.
Thank you, sir. Another question from Professor Prendra Kumar. Sir, could you explain SN curve again?
Yeah. What explain? Okay, SN curve is a very standard way of one of the way to see the fatigue performance. Now, what happens is that SN curve is a stress. It can be your design stress, and is a number of cycles to failure. So there are very standard machine called, I think, if I'm not wrong, the name is a Waller machine by the person who invented them, and now very easily available in the market. So you put a sample in there and put a fixed stress there and just note the number of cycles it takes to fail it. Then for different stresses, you have the different number of cycles to fail, and you can create a curve. And then you know exactly that when you're using into aerospace application, for example, they are given, every component is given certain flight hours. So in the flight hours, you know exactly how many number of cycles it will go through, because now everything is being monitored. And then you replace that part before it fails. So that is how the SN curves are used and created.
Thank you, sir. This is another question from Professor Sudhakar Rao. How you can optimize the composite parameters by DOE or Taguchi for recycling?
Well, recycling, we have not used it. The question is that how you can optimize a parameter for
Composite
recycling.
parameters by DOE or Taguchi for
Yeah.
recycling.
We have not done that yet, actually. Recycling has been a small part of our research because our most focus was in the development of new material and to find application. But the thing is that one of the way to recycle a material is, for example, remelting, right? In the remelting, you have to just melt a material. So there are not parameters there which you can apply here. Unlike you go for DOE and Taguchi method when you have various parameter you want to control at the same time and come out at the best parameter. But two ways which we have tried is remelting, and to check the properties, it came out nice. The second is that when you machine a material, there are a lot of chips created. Now the chips has to be recycled also. So our efforts is only to how we can recycle by using the powder metallurgy method and check the properties whether they are still good or not, actually. So that is our efforts in there, but I have not seen yet anyone where you are recycling, there are multiple parameters and you're trying to optimize. That is mostly used in the wear studies, and lately it is also being used for the alloy design also, but I have not seen anything to my knowledge in recycling.
Thank you, sir. I request participants please unmute yourself and you can ask question directly to our resource person, or please type your questions in the chat box. We will ask on behalf of you. Sir, it seems no question. Shall we proceed with the vote of thanks, sir?
Yeah, sure.
Sorry, sir. One more last question, sir.
Yeah.
It is from Professor Sudhakar. How magnesium can be used as influence in modular cast iron?
Well, that is only a very small use of magnesium. It is always used to, if I recall, cast iron, the steel technology, it is used to spheroidize the graphite flakes. So I think it's not modular, but the nodular, if I'm right. That is one of the main use of magnesium as a trace alloying element in that. But having said that, I think that is already very well established in the literature, because as a student 40 years back, I also studied the use of magnesium and cerium to nodularize the cast iron. So when you nodularize it, you are removing the stress concentration sites which are given by the graphite flakes, and you improve certain properties like tensile strength and toughness. But having said that, it is all very standardized.
Okay, sir. Sir, another question from Professor Pankaj.
Yeah.
Can we synthesize magnesium using laser ablation?
Okay.
Top-down
What kind of synthesis are you looking for? Are you trying to create alloys? Are you trying to create parts? Or what are you trying to achieve actually by laser ablation method?
I request Professor Pankaj, you can unmute and you can elaborate your questions. Sir, in the chat box it mentions nanoparticles. That is okay, sir. What kind of synthesis method? You please can unmute, can elaborate your questions, sir.
We want to see that, are you trying to introduce nanoparticles in magnesium using laser ablation in the bulk, in the surface? Means what is the ultimate objective?
Sir, Professor Pankaj, sir. Please unmute yourself, sir. Could you elaborate your question, sir?
Okay. It's all right, but I will just give an idea that yes, you can use a laser, but as I said, that it depends on your final objective. You have to ask yourself that why you want to use laser. Is it going to give you additional advantage? And what kind of temperature are you going to experience on the surface of magnesium in case you want to change the surface? Because remember that the boiling point of magnesium is 1093 or something like that, close to that. So basically, magnesium may evaporate also faster. So if your laser energy is strong, then you have to control that energy. If you're able to control the energy, yes, you can use it for the type of processing you are thinking at this point of time. Yeah.
Thank you, sir. Thank you very much. So now let me proceed with the vote of thanks, sir.
Yeah.
We thank you very much for your excellent presentation. Explained that how we should be eco-friendly with nature. You have explained the application of magnesium in various fields: material, abundance, and sustainability, non-toxic and cost-friendly. You have started with current issues with the planet Earth, the consequence of global warming and its evidence, the importance of a Paris Agreement and sustainable Earth and CO2 emission, improving the health planet Earth, and magnesium provides the opportunity for fuel efficiency and emission reduction, magnesium and human health and the importance of magnesium and eco-friendly magnesium and its lightweight. And it is we short of magnesium. Are we short of magnesium? Yes, no. It is 12 times more than aluminum and more than iron also. And you have explained the past and present applications in automobile field and use of magnesium processing techniques, example disintegrated melting furnace, powder metallurgy route, and the microwave sintering setup, reinforcement in nanotech length, and more, sir. And high performance alloys, nanocomposites, and dynamic behavior, high temperature behavior, grip performance, wear ratio, machinability of nanocomposites of magnesium, and the saltwater corrosion. And finally, you have explained the silico, nanosphere, nanocomposite, and future in magnesium material development. You have explained clearly how this cutting-edge material science, particularly magnesium, to be used by engineers for the practical applications in the current scenario. Thank you very much, sir. Thank you, sir.
Thank you. It was a pleasure. So, yeah. Is there anything else left, or I can leave the?
Yes, sir. Yes, sir. Actually, we want to inform our participant for a further session, next session, sir.
Okay. Yeah.
I request Rajesh, sir, you can present next session, sir.
Okay. Thank you.
Yes, the next session starts at 2 p.m. I request all the participants to please join 1:45 p.m. itself. It is given by the Professor G. Mohan Rao, Department of Instrumentation and Applied Physics, Indian Institute of Science, Bangalore. And the topic is carbon nanostructures for energy and environmental applications. I request all the participants, our morning session ends here. We will join once again around 1:45 p.m. Thank you for all.